Step 4 is, let's see how to convert a one-to-n relationship into a table. For that, let's take an example. You must be knowing this, we have already seen it, maybe works for. So if an employee is there, let's take the same example, employee entity, and there is a relationship, and there is department entity. Okay, this is employee entity and this is department entity, and the relationship is works for. So an employee works for a department, right? And according to the meaning of this, let's first talk about the meaning, the semantics which you got from the requirement analysis. Let's say the requirement said that every employee has to work for at least one department and exactly one department. Okay, and a department can have many employees, right? Then what happens is, employee is going to participate totally in this relationship, right? Because every employee has to belong to one department. Or let's leave that restriction, because when we delete a department, some of the employees might not work for the department. Let's say it is not total participation, it is partial participation. But then let's assume it this way: a department can have many employees, right? Then what about the cardinality? So if you are writing it in terms of cardinality, here it will be 1 and here there will be 1, which means an employee will work for only one department, but a department can have n employees. It is counterintuitive, even though the maximum number of relationships in which an employee entity can participate is 1, we write 1 that side, and even though the maximum number of entities that a department can participate in this relationship is n, we write n this side, right? But anyway, the one which has got n, that is going to participate in only one relationship, okay, maximum, and the one which has got 1, that is going to participate in different. Okay, so you have to think it this way. So n side is actually participating only in one relationship, every entity, but one side is participating in n relationships. Okay, now since these two are already strong entities, let us assume that there is employee number here, which is the primary key for this, so it is strong, and then employee name here, which is an attribute. Okay, and now here also we have department number, which is the primary key, therefore it is strong, and there is a department name, right? And let us say there is one attribute for this works for also, maybe the start date, the date in which he started working for that particular department. Fine. Now what I wanted to see is how to represent this particular relationship. We already know that for strong entities we already have the tables, the relations. So one relation is going to be this way. So one relation is going to be this way: employee is having two attributes. This is the employee relation, right? One is employee number and other is employee name, and it is a primary key. And we know that department is also having two attributes. One is department number, which is prime attribute, and department name, right? Now what we are supposed to do is represent this relation. So only way to represent a relationship is always using the foreign keys, right? In case of 1 to n or 1 to 1. So in this case of 1 to n or 1 to 1, we are supposed to use the foreign key concept, right? So how are you going to put the foreign key? Should I put the foreign key this side or that side? Which means should I put the department number here and then make this refer to this, or should I put employee number here and then make it to refer to this? Which one makes sense, which one is meaningful, which one is possible in fact? So if I put the department number here and make it refer to that side, then what happens is, for every employee we know that maximum he can work for only one department, therefore we need to represent only one value here. in case if you try to put with the department number, department name, the employee number also, it means that we have to write all the employee numbers who are working for a department. It turns out that for a particular department there are more than one employee working for it. Therefore, you might have to put more than one value here, which makes it multi-valued. And we already know that there is no provision in order to put a multi-valued attribute in just one single column. We need a separate table. We shall see it later, right? Therefore, putting all the employee IDs who work for a particular department in just one tuple which is related to that department is impossible, right? So the logical way or the only possible way is have the take the n side, which means the employee wherever there is n, take the n side, right? And then in that n side you should add the foreign key which is going to refer to the primary key of the other side. Got it? Therefore, it is not meaningful to include this one, right? So meaningful is take the n side is employee, and add the primary key of the one side here and see that it is going to act as the foreign key, and that foreign key refers to the primary key here. Got it? And now every employee has to have a department number, and the department number should already exist in this table, otherwise that referential integrity will take care of it. Got it? Okay. And now one other thing is, what are you going to do with the attributes which are associated with the relationship itself? The same thing. Go to the n side and you add the attributes. So whatever you are going to add it on the n side itself. The reason why am I doing this is because on the n side every entity is participating only in one relation, or for every employee there will be only one department. But then on the other side, for a department there will be many employees, and I will not be able to add all of them in just one tuple. But here, I can add the department name in one tuple, right? Therefore, I am going to have here, this particular start date also, right? So this is how we can implement this this particular relationship, right? So this is the implementation of 1 to n. See, in the earlier step we have seen how to implement 1 to 1 relationship, and here we have seen how to implement 1 to n relationship. In both the cases, we are converting the relationship into actually a foreign key, not into a table itself, right? We are actually making one foreign key refer to the other side, and that is how the entire relationship is represented inside it, right? We are not using a special table. Okay, fine.